Welcome to Fascinating Frontiers, episode 34. Today is March 2nd, 2026. A total lunar eclipse tonight will turn the full moon blood red, visible to over 3 billion people. A total lunar eclipse tonight will turn the full moon blood red, visible to over 3 billion people. Speaking of that stunning celestial show, let's dive right into why this eclipse is more than just a pretty sight. It's a chance to understand our planet's atmosphere in action, according to space.com. Tonight, the full moon will slip into Earth's shadow, and as sunlight filters through our atmosphere, the shorter blue wavelengths scatter away, leaving that eerie red glow on the lunar surface. This is the last total lunar eclipse we'll see until sometime in 2028 or 2029, so if you're in the Americas, Europe, Africa, or parts of Asia, grab your binoculars or just step outside. It's visible to the naked eye for over 3 billion people worldwide. What fascinates me is how these events reveal atmospheric scattering, the same process that makes sunsets red, and they give scientists data on things like volcanic ash or pollution levels high up in the air. Eclipses like this have inspired skywatchers for centuries, from ancient myths to modern astronomy clubs organizing viewing parties. It's a reminder of how connected we all are under the same sky. If the weather cooperates in Vancouver, I'll be out there myself, pondering what other atmospheric secrets the moon might reflect back at us. Now, shifting gears to something that's rewriting the books on our closest cosmic neighbor, let's talk about those Apollo moon rocks that are finally bridging a decades-old debate in planetary science, as detailed in Universe Today. Researchers have reanalyzed samples brought back by the Apollo astronauts, and their findings show the moon didn't form from just one dominant source like purely vaporized Earth material or solely from the debris of a massive impactor. Instead, it's a hybrid origin, mixing elements from both Earth and that ancient colliding body about 4.5 billion years ago, which resolves conflicting theories that have puzzled scientists for years. By examining isotopic signatures and mineral compositions in these rocks, they've pieced together a nuanced story of the giant impact that birthed the moon, refining our models of early solar system collisions. This isn't just lunar history. It could help explain peculiarities in moons around other planets, like why some have odd compositions or orbits that don't quite fit simpler theories. The human angle here is incredible. Those samples were collected by astronauts risking their lives, and now, with advanced analysis techniques, they're still yielding secrets half a century later. It makes me wonder what else we might uncover as tech improves. Could this hybrid model predict formations in exoplanetary systems we're just starting to observe? What other treasures from the Apollo era are waiting to be unlocked? On a different note, with space weather always a wild card, I'm excited about this new forecasting system for violent solar flares, reported by Universe Today. Scientists have developed a method that can predict major solar flares, those powerful X-class eruptions, up to a year in advance, and it's already been validated by recent events on the Sun. The system looks at patterns in solar activity, like magnetic field changes, to give us a heads up, which is crucial because these flares can disrupt satellites, power grids, and even airline communications here on Earth. Why does this matter? Well, in our increasingly connected world, a big solar storm could knock out GPS or cause blackouts, so early warnings let us protect infrastructure, maybe by powering down sensitive systems in advance. From an engineering standpoint, it's a game changer for satellite operators and space agencies, allowing better mission planning around these unpredictable solar tantrums. Personally, as someone who geeks out over the sun's dynamics, this feels like peeking into the future. Imagine how it could safeguard future Mars missions or even orbital habitats. It's a step toward taming the sun's fury, and I can't wait to see it in action during the next solar maximum. Speaking of the vast unknowns out there, a new study is tackling the Fermi paradox head-on, estimating that alien civilizations might have surprisingly short lifespans, according to Universe Today. Researchers used mathematical models to analyze why we haven't detected intelligent life elsewhere, concluding that advanced societies in the galaxy probably don't last very long, maybe due to self-destruction or other existential risks. This reframes our search for extraterrestrial signals. Instead of assuming long-lived empires, we might need to look for brief bursts of activity like radio signals that flare up and fade quickly. The significance here is huge for SETI efforts. It suggests we could be missing signs because we're looking in the wrong temporal windows, or that isolation in time is as big a barrier as distance. On a reflective note, it highlights potential pitfalls for our own civilization, like climate change or nuclear threats, urging us to think about sustainability on a cosmic scale. As a space enthusiast, it makes me both hopeful and cautious. Maybe we're not alone, but timing our cosmic hellos just right could be the key. What if the signals are out there, but we've just missed the window? Now let's turn to some groundbreaking work on building for the future, with laser 3D printing being tested for lunar bases, as explored in Universe Today. Researchers have used lasers to fuse simulated lunar regolith, that dusty soil on the moon, into strong, durable structures, essentially printing building blocks right from local materials. This in situ resource utilization could make constructing habitats way more cost-effective, avoiding the massive expense of shipping everything from Earth. The engineering challenge is fascinating. They've had to tweak laser intensities and fusion techniques to create bricks or walls that withstand the moon's harsh vacuum and temperature swings. For future exploration, this means sustainable outposts where astronauts could 3D print shelters, landing pads, or even radiation shields using robots ahead of human arrival. I love the practicality here. It's like turning the moon's own dirt into a construction site, and it ties into broader plans for Artemis missions or international lunar villages. Imagine the first lunar base rising from regolith dust. It's a tangible step toward making the moon a stepping stone to Mars. Next up, in the realm of extreme survivors, tardigrades are being tested in Martian soil simulations, with intriguing results from Universe Today. Scientists exposed these microscopic water bears to conditions mimicking Mars, think thin atmosphere, radiation, and regolith chemistry, to see if they could survive or even thrive. The findings suggest tardigrades might help us evaluate if Martian soil could support life forms, acting as bioindicators for habitability without us having to send complex labs. Why is this significant? Tardigrades are famous for enduring space's extremes, so their resilience could reveal whether Mars has hidden pockets friendly to simple organisms, informing astrobiology searches. From a scientific curiosity angle, it's fun to think of these tiny critters as our scouts. They've already flown on space missions, and now they're proxy testers for alien worlds. My take? It underscores how Earth life might adapt off-planet, potentially guiding contamination protocols for future rovers or human explorers. Who knows, tardigrades could be the unsung heroes in proving Mars isn't as barren as it seems. Shifting to actual space missions, ESA's JUICE spacecraft has captured some stunning images of an interstellar comet, as reported by Universe Today. While en route to Jupiter, JUICE snapped detailed views of Comet 3I Atlas, revealing its gas halo, streaming tail, and active jets spewing material. This is exciting because interstellar comets like this one come from beyond our solar system, offering clues about the compositions and origins of objects from distant stars. The data helps us understand how these wanderers form and travel, potentially carrying pristine materials from the early universe that differ from our local comets. From an engineering perspective, it's a bonus for JUICE, a mission primarily focused on Jupiter's moons, to snag these opportunistic observations, showcasing the spacecraft's versatility. As someone who's always thrilled by interstellar visitors, this reminds me how our probes can multitask, gathering data that might rewrite what we know about the galaxy's building blocks. What stories are these comets carrying from their home systems? Finally, on the communications front, NASA is detailing plans for a new Mars orbiter to handle data relay, according to SpaceNews. Funded by recent legislation, this orbiter will serve as a reliable communication hub for rovers, landers, and eventual human missions, specifying requirements like high-bandwidth links and orbital stability. The why matters because current Mars orbiters are aging, and with more missions planned, like sample returns or crewed explorations, we need robust relays to avoid data blackouts. It's an engineering puzzle, designing something that can withstand Mars radiation while providing seamless connections back to Earth, perhaps integrating laser comms for faster transfers. For future exploration, this could be the backbone enabling real-time oversight of astronauts or autonomous robots, turning Mars ops from intermittent to continuous. I'm curious about the human story, teams at NASA piecing this together amid budget constraints, all to keep our red planet dreams connected. It feels like laying the phone lines for an interplanetary neighborhood. Before we go, next time, we'll be watching for updates on Firefly Aerospace's Alpha rocket, which scrubbed its return-to-flight launch yesterday due to winds, as they aim to test those improvements for small satellite deployments soon. That's Fascinating Frontiers for today. If you enjoyed this episode, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for listening, and I'll see you tomorrow.
drifting softly through the black. A million stars behind our back. The void hums low.